That's so cool.
It's okay.
It's going to be amazing. Yes. It's going to be amazing.
That's probably enough drinks for tonight.
That's so cool. It's going to be amazing. It's going to be amazing.
That's probably enough drinks for tonight.
Yes. That's so cool.
It's okay. It's okay.
Yes. That's so cool.
That's probably enough drinks for tonight.
That's so cool.
It's okay.
Yes. It's going to be amazing.
It's okay.
Yes. That's so cool.
That's probably enough drinks for tonight.
Hello, everyone.
Hey,
Thanks for welcome to our stream this week. Mario Garcia, a technical evangelist at Percona. Today we have Marcos Alve, Principal Support Engineer, who will talk about how to secure MySQL. Thanks, Marcos, for joining us today.
Yep, thank you for having me. And well, let's go straight into it. I don't think I need to explain what security is to everybody, but I still have one very quick slide about it. Let's share. There you go. Coming up. Can you see my screen?
Yeah.
Yep, amazing. Let's start then. Okay, welcome to our Securing MySQL. I'm not in depth, rather we're going to go through what things you need to keep in mind and what is the smart way to approach things. So big long agenda, we're not going to go through all this. So what is security? And I'm going to give a very brief definition so we can see why the things we're going to discuss later are important. Security is keeping unauthorized persons from accessing sensitive data. I guess that's like very about preventing denial of service. These are the three things I believe are the most important and what most people has in mind when talking about security. So when we look at the features and functionalities that we're going to discuss, they are all geared towards these goals. All right. So before talking about the database security, let's talk a bit about operating system security, because the database runs in an operating system. So layer of protection is in MySQL. We have, in Linux, we have Secure Enterprise Linux, which provides enforcing of contexts. And with that, you can prevent many type of security issues. So basic commands are get enforce to make sure it's in place and set enforce. And we have documentation on how to enable SE Linux and still have a working database, because many times SE Linux is going to prevent your database from working. So don't disable it. Make sure you configure it properly. And again, don't disable it. It's an important bit. Audit D will give you an OS level audit daemon, and it's going to record events. For example, SE Linux, when SE Linux forbids something, it's going to be logged by auditctl. But you can also log other stuff. You can create audit rules to, for example, log who is sending kill to a process, or you can you can log audit via audit log who is trying to access some file or who is trying to delete a file. So you basically can create rules that follow certain actions on certain objects and have a log of those actions. Make sure your operating system uses two-factor authentication. I know some two-factor authentication methods can be spoofed, but it's an additional layer of security. And security is about layers. Make sure you have IP tables properly configured and with only the necessary ports open. Sorry for that. Limit your sudo capabilities. So don't let your users run sudo for any command. Rather, make sure they only can run the commands that they need to use their services. Sorry for that. So then make sure you have an up-to-date OS. Make sure you're applying security patches to your OS. Don't run MySQL as root. That will then allow a user from within MySQL to select to access files in the file system that MySQL shouldn't be accessing. So if MySQL D runs as root, basically MySQL D is root and is capable of destroying files or reading files that can contain sensitive data. And then make sure that varlib MySQL D is only accessible by the MySQL user or whatever Linux user you use to run MySQL. Okay, application security. This is the most important. So I'm going to talk about MySQL security, but MySQL security, I would say if you want to keep your data safe, MySQL security is like 30%, application security is like 70%. So because we're talking about data safety, I'm going to talk about application security. Most important, sanitize your inputs. I guess everybody knows this, but sanitizing inputs is the most important thing you can do for security. Like there is little else. There are a few things more important than this. Like I don't know how to say it, but this is the most crucial thing you can do. Everybody schemes on this, and that's how they get attacked successfully. SQL injections are still the #1 security problem for all databases around. Also, when your application gets a warning or an error, don't ignore it. You should be capturing those, logging them, and later handling, making sure that your application and the database are always in agreement and that your application is always using up-to-date functions and methods within the database. So don't ignore those warnings, don't ignore those errors. Then rely on a user with only the necessary grants. Don't give all the privileges to your application users. So application users should only have the minimum set of grants they require. This depends on the application, of course. And sometimes some applications will require dangerous grants, privileges. I will try to create separate users for those and not like the main application user. But yeah, it's very, application dependent, but try to reduce the amount of privileges you provide to your application users. And did I mention sanitize inputs? Because that is very important. And you have to keep in mind that your configuration files and your configuration tables are also inputs, and you cannot trust those blindly. Just always verify and sanitize your inputs, even if you believe it's your own input. Someone might have spoofed that, and if you are not sanitizing those, then you will get attacked through that vector. Then use assertions and abort if the inputs don't comply with the expected format. You have to abort, throw an error, and keep a log of these assertions, because these are possible attacks. And really, really, really sanitize your inputs. There's a very famous joke about Bobby tables, where someone called their son Robert, quote, parenthesis, drop table. And yeah, it's little Bobby tables. And, I hope the school people learn to sanitize the database inputs, because really not sanitizing inputs is, the easiest road for someone to steal your data or to delete your data and deny you service. So this is the most crucial thing you can do for your security. It's not on the database, it's on your application. So go there and start sanitizing. All right, now, on to MySQL authentication. So authentication is proving that we are who we said we are. So basically login, right? Which is different from the access control, which is I am Marcos, and I was able to prove to the database I am Marcos. But now, do I have the privilege to read this table? So that's the access control. this is the authentication. So authentication, prove who you are. The most well-known authentication is local authentication. This is the database itself is doing the authentication. It keeps the user and the passwords and does all the management. I'm going to talk about MySQL 8.0. I'm not going to go into much details about 5.7 because it only has 1 year left of life. So I expect everybody is upgrading to 8.0 by now. So in MySQL 8.0, the default authentication plugin is something called caching SHA-2 password. Caching, it's because it keeps a cache of established connections, so you can get faster reconnections. And SHA-2 refers to the hashing algorithms. So original algorithm was SHA-256. Right now it's still SHA-256, but SHA-2 is a whole family of algorithms. So that's why the name. And basically, if you want to make sure a user is using caching SHA-2 password, oops, I have an extra underscore there, sorry. This is the alter you want to use. Also, caching SHA-2 password, it's RSA based. So even if you don't use secure connections, even if you don't use SSL, TLS to encrypt your connections, the password itself will be still encrypted. So it's an additional layer of security. Then when you are authenticating to MySQL, always the user have a user part and they have a host part. So user at example. Example is the host name in this case. MySQL is going to try to verify that the host matches with the IP address to which MySQL can resolve that host name. So that is, in a sense, an added security measure. It's also a potential performance problem. So, there's a trade-off in this case about, being more secure and having less potential performance issues. This is, of course, a business decision. In a secure environment, I will try to stick with I will avoid skip name resolve. Apologies, I have a dry throat. So in a secure environment, I will not use a skip name resolve. And also, host names can include wildcards. So I could name my host like example.%, and any host that starts with example will be valid, and it will not get skip name resolution. It will not get name resolution because you can not resolve like a partial host name. So this is also something to be careful with, right? Like, don't abuse wildcards because they can allow people to sneak in. Another important part of authentication is having safe passwords, having a healthy password update policy. And to help with enforcing policies, MySQL introduced password expiration. Basically, we have a way to say, okay, this user's password will never expire. This user password will expire in 90 days, or this user password will expire in the default amount of time, which is defined by default password lifetime. And then we can decide what to do once we find a user with an expired password. Should we disconnect or allow it to connect to the MySQL in the sandbox mode where he can go ahead and update his password?
Marcos,
yep.
I have a question. When we talk about privacy and security, one of the best practices that most people recommend is to change our password every certain amount of time. Would this apply to databases? Would this be recommended to databases?
Yeah. This feature, password expiration, is precisely for that. Is what allows you to enforce that. It's not that the users are going to have a chance. Rather, we as the administrators are going to tell, okay, you have to change your password every 90 days or every X amount of days, because we want people to keep refreshing their passwords. So yeah, it's an important security measure, certainly. And because a password leak or a brute force attacks, or someone was able to saw you typing your password or whatever, changing your password often makes it safer. And this is going to force people into doing that, whether they want to do it or not. So yep, exactly, this is for that.
Thanks.
Sure. Okay, continuation of local authentication. Sometimes when you are rotating passwords and you have hundreds of application servers, rotating the password is not so easy. And there is a feature that makes this much, much easier, which is dual passwords. Basically, I can have a user that has two valid passwords. And so I can create the new password. I will do alter user identified by the new password, and then I will say retain current password. And with that, my application servers are going to be able to log in with the password they still have. And then I can go and deploy the password change on the application with a new password. And that password will also be valid at the same time. And when I am done updating all my application servers with a new password, I can go to the database again and do discard all password. And now, I was able to rotate my password with zero downtime and zero impact to the application. This is such a simple feature, but it's so important. And it helps precisely with this, with enforcing rotation of the passwords and without making it such a pain in the neck for application owners. So, if you're enforcing password expiry, please, be mindful and also find a way to use dual passwords so people can more easily rotate their passwords.
Marcos, there is a question in the comments.
Yep.
Is it possible to automate password rotation?
Yeah, well, yes. Yeah, sure. Why not? Like, you can automate everything, and just, you will have a script that generates the password. Then it does the alter user, identified by new pass, retain current password, then updates your applications so they use the new password, and then comes here and does the discard old password. You should never be waiting until your password expires, right? Like, if your password expires in 90 days, the automation should do it on day 89, right? But yeah, it's possible. I'm not sure where you are going to store the generated password. I guess you could have something like HashiCorp Vault, which is a secure vault, and you could keep your passwords in there. Oops, my bad. Apologies. Hit escape accidentally. So yeah, it's totally possible. It's not part of the database. Like, that's something you will do with your own scripts, like Chef, Ansible, Puppet, or whatever you use. I hope that answers the question, Enrique. And then password validation. We not only want people to rotate the password often, we also want them to use safe passwords. For example, passwords that don't contain their own username, or passwords that don't contain words from a dictionary file, passwords that have a minimum length, that they have uppercase, that they a minimum of lower and uppercase letters, a minimum of X numbers. I can't remember what policy was. I guess it's strict. I can't remember top of my head what policy is. I'm sorry. And a special char count is just that, how many special characters, non-number or non-alphanumeric characters your password must have. So again, I guess you will want to combine all of them: expiring password, validating password, and dual passwords. There are functions that will allow you to verify that your generated password complies with the policies imposed by the component for the validate password component. So yeah, this is also an important bit, because dictionary attacks are well known, easy to implement, and have had great success in the past. So if you keep using dictionary words, you're gonna keep being vulnerable to this type of attacks. Okay. Finally, we were talking about local authentication. We should now talk about remote external authentication. Basically, in big enterprise where you have your own LDAP or your own Active Directory, people doesn't want to have more users. So this is LDAP. Active Directory is kind of a enterprise single sign-on for internal use. And basically, Percona Server has this auth-pam plugin. And with the auth-pam plugin, you can use the PAM stands for Pluggable Authentication Module. And it's a Linux facility that allows authentication in a pluggable way. So there is not a single way, rather you combine plugins and modules to build up the authentication you need. In this simple example I have here, I am using PAM Unix, which basically authenticates against /etc shadow file. So this is not safe for production. This is just a silly example, but basically you will have etc pamd MySQL, and you will have these settings. And then you will have a user. On the user, when creating the user, instead of doing identify it with caching SHA-2 password, you will do identify it with auth-pam. And this is going to trigger the PAM plugin. The PAM plugin is going to go to etc pamd MySQL, and it's going to find this file, it's going to parse it, and it's going to apply these authentication methods. So we have several blog posts about how to implement it with LDAP and Active Directory, and we provide support on how to do this. It's not the easiest thing to set up, but once you have it working, it's just like any regular login. It might require an additional layer where to type in a safe password, because the password input for MySQL used to be plain text. So to avoid plain text input, the auth-pam plugin also provides dialog.so, which is a dialog where you type in a password safely. So you could also write whatever authentication plugin you want for PAM, configure it in PAMD MySQL, and then use it. Like, you could implement your own if you want. For example, if you want to use Kerberos, I'm pretty sure you could do it. So that kind of stuff. Then now, yeah, that was authentication. That was proving we are who we are. And now we have ACL, Access Control List, which is, I am Marcos, can I do this? So MySQL Access Control is composite. You compose the access control by granting privileges on certain objects. So I have some examples here. For example, I can do grant, insert, update, delete on this database, on all the objects of this database. But you could go to the detail of granting select only on certain columns of a table. And that might be important if you have like users that you want them to, read from certain tables, but you don't want them to access sensitive data that isn't there. Then you could just provide them select only for the non-sensitive columns. And as we mentioned it before on the application side, you have to make sure that you're only providing the bare minimum necessary for each user. Just security is about that. Provide the bare minimum to access on an as-need basis. Don't provide full access before it's needed. And then, well, especially some grants are normally unnecessary for applications like super file process. Like 99% of applications won't never need this. Just avoid those. Those are dangerous. And then to simplify grants management, you can create roles, and you create a role, and then you grant the privileges you want to that role. Oh, and I forgot to show how to bind the role to the user, but basically there is one more create command for the user or alter command for the user, where you assign the user to one or more roles. And then there is one more access control level, which is called definer. And when you create a view, when you create a stored procedure, when you create a routine, you can set a definer, and you can tell that the security context for that view or routine is the definer. And what this means is that you might not have access to table X, but the definer does have access for the table X. And you will have access to execute the view or execute the routine. And then you will have indirect access to table X through the definer privileges. So basically, when you do select from this view, and that view was defined by the privileged user, you are running with the privileges of that user for the context of that view. So this is another way to limit privileges for people, while at the same time allowing them to access somewhat privileged data in a controlled way. All right. MySQL encryption. I guess this is what everybody has in mind when they hear MySQL security. SQL encryption is a convoluted area of the code, has changed, the SSL libraries change. And in all honesty, I'm not a security expert. So again, I can just say that it takes time to implement, or it takes some trial and error, because again, there are many guides out there, and each guide is for a different version in a different OS and for a different distribution of MySQL, And so MySQL, Percona Server, and MariaDB, they all have small little differences in how they link and which library they have compiled against. And based on that, what TLS version you can use, and so what you might need to create different certificates and whatnot. But basically, MySQL encryption is about that. It's about encrypting all the data to make it not accessible. So there are multiple levels of encryption. I'm not gonna talk about how to implement this. I'm just gonna talk about what they are and what they are important. So over the wire, this is like the most basic and what we see most people using is basically you create certificates for your server, you create certificates for your user. Those certificates should be created by using the same certificate authority, and with that, the client and the server can establish secure communications, which avoids eavesdropping, right? So avoids a man-in-the-middle attack or observe someone sniffing traffic. So over-the-wire encryption with TLS is to avoid traffic sniffers or man-in-the-middle attacks. Then transparent data encryption is the encryption for your tables. And it's called transparent because your application will never realize that the data is being encrypted behind. Basically, when you create a table, you will say create table blah encrypted, and that's all. Or alter table blah encrypted, and that will encrypt the table. If you alter a table and encrypt it, it's going to recreate the whole table, because otherwise the data wouldn't be encrypted. So and that will make the data not accessible. When you use transparent data encryption, the data is not accessible to someone outside the MySQL server. But if you are inside the MySQL server, if you have a user and that user can read from the table, then the table is not encrypted. So this is to prevent stealing data from the file system level. Apologies, I have a bad throat today. So transparent data encryption is for that, is to prevent stealing data at the file system level. Like if I steal your IBD files, if I steal your table spaces, I won't be able to use those on another MySQL because I don't have the encryption keys. And this brings me to key management. So depending, we have two plugins, Keyring File or Keyring Vault. Keyring File is going to keep the keys on a file, on the file system. So you could keep that file on a separate volume, and later you could unmount the volume and request a password to mount it again. That will make it fairly secure. Still, we don't recommend Keyring File for production deployments. What we recommend is Keyring Vault, which again uses HashiCorp Vault as the plugin, as the key storage. And this is much safer, and the vault is always protected by a password. And well, then you also have to define your key rotation. There's a whole heap of literature about this. I'm not going to go into this again. This is a really deep topic, so I'm just going to stay on this. Transparent data encryption is to prevent people from stealing your files and have them be useful. Other stuff you can or you should encrypt, because people could also steal those files and still have useful data, is the IB data one, which is your system table space. Your binary logs, those are important to be encrypted. You should encrypt your redo logs, your write-ahead logs. Those also contain your data. Your undo logs, those also contain your data. Your temporary files also contain your data. And finally, the double write buffer. This has been deprecated on later 8.0, as it's now always encrypted for tables that are encrypted, and it's always not encrypted for tables that are not encrypted. So the double write buffer, it's not going to be needed to be handled separately. It's going to be handled automatically in the future. So Another form of transparent data encryption is at the disk level. Sorry, before we go into there, one note about data encryption. When you are encrypting data and then you want to decrypt it, you want to access the data, you're using more memory. You're keeping the encrypted data in memory you just read from the disk, and then when you decrypt it, now you have a decrypted copy, and now you're using more memory. So when you implement transparent data encryption, it has a price for CPU, for memory, and possibly for storage. Encrypted data tends to be larger, tends to have a bigger footprint than non-encrypted data. So again, keep that in mind. And if your boss is asking you to implement it, make sure to mention the extra cost. And now, to the next level, which is disk level encryption. This is at the operative system. I could have mentioned it before, but I thought it fitted better here. And there's something called LUKS, the Linux Unique Cryptographics Key System. I can't remember the acronym for LUKS, but it's basically the de facto industry standard for disk encryption in Linux. These make things very slow. That's all I'm gonna say. Like, it works, sure, and it's easy to implement because you just encrypt the disk and you don't have to do anything else. And the double write, the temporary, the undo, the redo, the bin logs, and everything is going to be encrypted. But this is slow, and also it's not very safe because while the disk is mounted and at that point is decrypted, this is more geared towards someone stole my laptop, or someone stole my server, or someone stole my storage drives, and I don't want them to be able to mount those drives without having the password. So it's secure while the disk is shut off. Once someone is able to mount the disk and has the right password to mount it, then it's no longer secure. So while the database is running and operating, this is not providing security. This is just providing encryption in case someone later goes ahead and steals your drives. So I'm not sure it's my favorite method of encryption. I will not implement this. Then column level, sadly, this does not exist. There is no such column level encryption. So what am I mentioning here? I'm mentioning because it brings us to application level encryption. Again, this is also could have been mentioned at the application, on the application slide, but I think it makes more sense to mention it here. Sometimes you truly don't want your data to be unencrypted anywhere. And the way to do that is to actually encrypt it on the application. If you truly don't want that data to be insecure at any stage, then encrypting on the application is the right thing. This is like a very silly pseudocode idea of how you will do it. You have your data, super secret content. Then you're going to get your data key from your key management system. You're going to generate a key, blah, blah. You're going to give that a name to identify it. And then encrypt it. You're going to encrypt the data. So crypt encrypt my data with that key. And then I'm going to get the ciphertext, which is the piece of the key. So this is a 2 parts key. And one has to be stored along the data. And so I will insert into my table the ID of the row, the data I want to keep secret, and this ciphertext. And Then when I retrieve the data, I will pull the secret data and the key, and then I will use my key management system decrypt, and I will use the key, and then to get back the data key. See, and with that I can do actually crypto.decrypt. So first I decrypt the key with the piece I stored on the table, and then I decrypt the data with the key I decrypted. So it's a two-step decryption. Oh, Matt Yankovic, what a pleasure to have you here. What an honor. I'm glad you're having fun. I'm glad you're having fun. So, okay, this is like the paramount of security. Like, if you are working on some super secret project, you probably want to do something like this. It doesn't come without problems, right? Like, how do you index this? How do you actually search this? Well, no, you're going to have to perhaps associate your search tags with the IDs and keep them elsewhere, or you're going to have to figure out a way to, associate records with the potential ways you want to look for them. But certainly, there is no way for MySQL to decrypt the data to keep it indexed. So, no, that's the main disadvantage of this. But it's the most secure method. Okay, then a bunch of miscellanea about MySQL security. So skip symbolic links can be an important thing, because if I put a symbolic link inside my data directory, and my symbolic link points to /mount/other disk, and if someone goes and replaces /mount/other disk with their own content, then MySQL is going to be reading from someone else's content and not the one we intended. So, not using symbolic links is safer because it avoids target swapping. Skip grant tables. Make sure you never have this on your MyCNF, because that's going to basically skip all the security MySQL provides. So it's only used for emergency recovery. Secure file priv, it's telling MySQL where is it safe to write. Because, if I do select into outfile /etc/hosts, I'm changing the host file. Or if I do into outfile /etc/shadow, then I am overwriting the Unix security file. So defining a secure location for MySQL to write, it's also important. This is a very little known one, skip show database. It's like when you are into the tinfoil paranoia level, you will go with not allowing people to do show databases, because that's how phishing and well-prepared security attacks work. They get little pieces of data, that you can easily recognize and that you believe only people familiar with operations and the company will have. If you have like a weird database name and I can gain access to the database name, I can tell you, oh, hey, can you give me the password to this database name? And you will say, okay, if he knows the name, he's probably an employee. Or, it helps me impersonate others, or it helps me build that impersonation of someone else. And it could be important data. So skip show database, it avoids unauthorized insight of what could be sensitive data to build an attack. Load local data in file. Usually load data in file only allows to load files from the MySQL data directory. The local modifier allows to load data from anywhere. Most people will want to use load local, but it could also mean they can try to read files for which MySQL has authorization of reading, and that the user should not have authorization of reading. So you might want to keep that disabled as well. And I forgot to put the variable name. I'm super sorry. Is loading file. I can't remember. Perhaps Matthew on COVID knows. I see questions. Is it a way to see something? I will get into the brute force part right now. So max user connections is to avoid, like, it will limit the number of connections a username can have active. It's kind of to avoid a single user hogging the server, which is a way to create a denial of service attack. And that's one of the things we want to prevent with security. So that's important. Max connection errors. This is the most simple brute force attack prevention. You know, it's just gonna, after X amount of consecutive failed connections, is going to block that host. So it's gonna block the IP address and not the user, because it assumes that someone from that IP address is trying to attack. This is a bit brutal because it really prevents any further connection from that host. So perhaps other user, I can't remember if it will apply to other user. I think yes, I think it applies to the IP, and the host is blocked for any user. So if user A had 100 failed attempts, and then user B comes later and tries to access from the same host, it's going to be blocked. Then we have access control plugin, and it's more refined, and basically you can define how many connections before we start doing something. Then what we're going to do is add a delay to each connection attempt, and this is going to make brute force attacks virtually very much impossible, because, you know, brute force attacks rely on being able to try thousands or millions of passwords. If I add just like a 1 second delay, then, you know, I'm making your life harder. If I add 15 seconds, then I'm going to make your life impossible. So that's just a way to control brute force attack. And you should keep an audit log of, we're going to get to the audit plugin later. But basically, yeah, you have to keep a log of failed authentication attempts. Then set password for root accounts. Alter table. Oh my God, alter user. I type faster than I think, obviously. And when it says alter table, it should say alter user. And, you know, like, make sure you set a password for root. In older MySQL versions, this was empty by default, which was a security disaster. So don't do that. Also, remove root accounts with remote access. So delete from MySQL user where user root, and host empty, because you don't want root to connect from anywhere else. Or actually, I guess a better delete will be and host not equals localhost instead of empty. And then you do flash privileges. Also remove anonymous accounts, and these are accounts with an empty string on the user. You don't want to have those. And finally, you don't want to have the test database, because it's a well-known default database, and like anything default tends to be insecure. I will correct this slide before we share with the general public. Apologies for the small mistakes. Okay, audit plugin. So the audit plugin is was originally created by MariaDB, then improved by Percona, and you know, I didn't got to produce like a full configuration detail here, but it's super simple. Like this will get you a working audit plugin. Like just that will get you a working audit plugin. And then you can configure, what actions get audited, what users get audited, what schemas or databases get audited, and it's really necessary piece of security, because when bad things happen, you want to have a record of what was going on to do a post-mortem analysis. At the very least, you should audit logins, and this is what Kike was asking. Yeah, like you have to audit the logins, and it's gonna show you if it was successful or not. And also, you should audit all the data manipulation language and selects for critically sensible tables. And to make this a reasonable thing, what we want is to log to a remote syslog. Like if it's a crucial, like if your security requirements mandate auditing, you probably want to, make that audit log live in a external remote location, because if you keep it in the same machine that is being attacked, it's likely that the attacker has the capability to also delete the log. It's a possibility, and we don't want to live out of possibilities. So remote syslog is the right way to go. So yeah, audit plugin, also an important bit of security. And
Marcos.
also, yep.
Yeah, there is a comment related with the slide where you show how to set up a password for a root account. Well, is it
All this, yeah, it's
is it the
secure
same? Yeah.
Yes, it is. The script is being deprecated at some point, and some people won't know the name of the script, and at least knowing what the script does is useful. But yeah, it is the same. MySQL secure installation, if I recall correctly, is the name of the script. Yes, sir. Right, and then we did audit. Okay, and also, why do we want to do audit plugin and we don't do like the general log or the slow query log? And the reason is the audit plugin is a buffered plugin, so the IO impact of the audit plugin is far less compared to the general log or the slow log. That's another big advantage of the audit plugin. So also the audit plugin supports different supports structured outputs, which the general log or the slow log don't have. And with structured, I mean it will output a JSON or XML or a comma separated values file. And with that, it makes it easier to have tools to process the audit logs. So that is that. Backups. Again, we said that one of the goals of security is to prevent data loss. So backups are part of that strategy. I'm not going to say much. I'm just going to say the bits that are important to security. One is store them externally in Glacier or S3 or whatever you want, somewhere where you can recover from ransomware. Ransom has always two parts, right? Like, I have your data. Do you want your data back? And you can say, no, I'm going to flip the bird to you and just, keep the data. I have a copy, whatever. But the problem is they get to keep the data. And as they keep to get the data, they can, leak the data or sell it or whatever. So once you're hit by ransomware, you're in a very bad spot. But yeah, at least if you can get your data back, it's something. It's going to be better than not getting your data back and getting the data leaked, both at the same time. Remember that backups should also be encrypted, especially if you're going to store them externally. You need to keep the keys to decrypt the backup as well, but don't keep them along the backup. This makes things hairy and convoluted, yes, but security is like that. And please verify your backups. Don't even if they are encrypted, compressed, and they are huge, and you have to go through a 48 hours process to decompress, decrypt, and test them. Believe me, the 48 hours are nothing when compared to data loss. Like 48 hours of data recovery is probably not going to get you very far. Testing your backups is going to get you your data back. So just make sure you automate backup verification. Pretty please. Just, do it. And then data masking. This is just a simple thing. When you have to provide your developers or your support company with a sample of the data you're using or with a copy of the data you're using and your data is sensitive, you want to do data masking. Percona has a data masking plugin, and it simply will convert, it has some functions to convert a credit card number to just the last 4 digits, or to convert an email address to a fake email address, and that kind of rewrites are very easy to do via proxy SQL query, where you can just, for the sensitive tables, if you could intercept the MySQL dump queries and rewrite those so they will apply the data masking. It's, again, something few people need, but if you need it, be aware that there is a data masking plugin and that you can do it via proxy SQL, which make things consistent and easier to repeat. And finally, I had one more. Data disposal. This is also, few people think about this, but once you drop the table, is it gone? Is it like very, very gone? Or is it still on memory? Or is it still somewhere in the disk because it was not, overwritten? So data scrubbing will take care of that. It's also a feature of Percona Server. Dropping the BFS cache will guarantee it's not in the operative system cache. And you also need to think whether you need to purge from the backups. And this is super hard. This is something you have to policy around, and you have to come to a business agreement on, if I drop this table from here, do I want to go back and get rid of the backups? How far back? How long we're going to retain those backups that still has this table? So this is something that you need to think about. There is no single simple solution. Everybody has different needs, and each business has different mandates regarding security. So this is purely business decision of how to deal with that. And finally, people. Hacks don't get done by super geniuses that can crack your 4096-bit RSA key. Rather, they are done like suggested in the on the right, with a wrench and people just intimidating you physically. And this, there have been many cases in recent times about people with millions of dollars in crypto wallets with bitcoins that have been kidnapped just to get the damn Bitcoin hashes. So this is how it works. People is the ultimate barrier and is the weakest barrier. So good security training for your personnel, good security mindset, it's about the mindset. Is how do I store my passwords? How I connect to public networks when I'm outside home? Do I plug my kid's pen drive to my work computer? All that stuff. It's really painful, and it's just a big burden. But we users at all levels in a company are the ultimate barrier and possibly the weakest barrier. And really, phishing and spear phishing and other phishing methods are by far some of the most efficient tools hackers have. So-called social engineering. It's a real thing. It's been done hundreds and thousands of times, and we got to be careful. So there is nothing I can advise regarding this other than comply as close as you can, or comply with your security mandates. Be careful and be mindful. And we are at the top of the hour. I hope you had fun, like my friend Matt Jankovic suggested. And I could take one or two questions. Again, I'm not a security expert, so be gentle with me. Pretty sure.
Yeah, if anyone has any question, please leave a comment wherever you're watching the stream.
All right. If none, then thank you, Beko. I also like people that participates in this, so thank you very, very much for your participation, man. All right. Then with that, was a pleasure that you joined me, and thanks for having me, Mario, and thanks, Edith, and thanks, Matt Jankovic. Again, it was such a pleasure that you still hang around with us here. Are you gonna do are we still gonna do the barbecue show one day, Matt? Would you invite me to one of those? How to balance between performance and security? Convince your boss to buy bigger machines. I mean, is your boss asking for security? I'm sure, so asking for bigger machines. That's all I can suggest. There is no balance. Security is a cost, and it's a sunken cost. It's gonna be there. You're not gonna get rid of it, and there is no magic way to make things faster. You have to take more memory, take more disk, and process double the data in CPU. So, and many of these things can be CPU intensive. So bigger machines are gonna buy you some performance. Also, it might not be linearly scalable. Like, if you were running in 24 cores with 32 gigs of RAM, it's possible that a 48 cores with 64 gigs of RAM, it's too much. Or depending on your workload, it might be that it's not enough. It's quite a bit workload dependent, because it depends on your data set, on your active data set. And so if you do very large table scans, those are gonna be super costly queries when you're encrypting. So there is really no easy way to balance. And also, if you do like tons of updates and you have to disposing the cached unencrypted version of the row in memory, then you're also inducing more work into the database. So that's not something that can be done. Let's say, like, I don't see a way to get rid of the cost of security. Security has a cost, and your boss has to pay for it. All right. Then with that, I guess we call it a wrap. Folks, thanks so much for joining us. Have a good time, everybody.
Thanks, everyone, for joining us. And thanks, Marcos, for sharing your expertise on this topic. So, and we will see in 2 weeks.
In 2 weeks, yeah, I think so. I'm about to travel. We have meetings. Yeah, in 2 weeks, I will see you, of course. It's just, I'm still here. All right. So, yeah, in 2 weeks.
Yeah.
Bye,
So,
everybody.
hi, everyone. Thank you for joining us.